In this video, I want to overview the two main algorithms used by clustering software to group customers into relatively homogeneous segments. Let's assume you plan to open 3 coffee shops to serve the coffee drinkers, depicted by these icons, living near Emory University. The coffee drinkers prefer a shop that is close to their home. It is relatively straightforward and easily seen on the map that there are 3 distinct groups of customers. But if we're going to get a computer to help us, we're going to need an algorithm for the computer to follow. We begin by randomly placing the 3 coffee shops on the map. Then we assign each customer to the coffee shop located nearest to them. But look, the purple customers would be better served if we moved the purple store to the center of the purple customers. So let's do that. Let's do the same thing with the green store and the blue store. Move each store to the center of the customers each is servicing. Now let's repeat the first step. We assign each customer to the store closest to them. This results in a customer colored green that could be better served by the purple store. So we color it purple. Then move the stores so that they're at the center of the customers they are servicing. Repeat the first step where we assign each customer to the store closest to them. This results in some of the blue colored customers shifting to be serviced by the green store. We color them green. Again, locate the stores so that they're the center of the customers they are servicing. So there you have it. We have reached an optimal solution. Knowing that we wanted to open 3 stores, we have located them so that the collective distance all customers travel to their closest store is minimized. This is an algorithm called k-means clustering. Next, using the same dataset, let's look at an algorithm called hierarchical clustering. Here we don't predefine the number of clusters, but instead iteratively group customers into segments that get larger and larger until we get to a point where combining any further would mean the segment is no longer relatively homogeneous. We use the same data as before. A customer's location is described by 2 dimensions. Let's call them X and Y. Computers are really good at doing the same task repetitively. The computer calculates all the pairwise distances between the customers, looking for the minimum distance. We find the 2 customers who are closest in distance and will service them with the same store. So let's combine them. Next, we find the next 2 customers who are closest in distance and combine them so they're serviced by the same store. In this case, it's a customer right next to the 2 we just combined, so now we have a triple. We continue in the same manner. Find the next 2 customers who are closest in distance and combine them so they are serviced by the same store. And again, and again, and again. Now we have another triple. Now we have a group of 4 and a second group of 4. A group of 4 becomes a group of 5. Then we reach a point where the distance is too big, so we stop. The 2 groups are too different, so we don't combine them. This is an algorithm called hierarchical clustering. How do you determine the number of clusters or segments? You are trading off parsimony, meaning fewer is better, for a richer description of the market. The more segments you have, the more homogeneous the customers in a segment will be, and the extreme being every customer is in their own cluster, i.e. a segment of 1. The intuition is to keep increasing the number of clusters until you get to a point where a measure of the homogeneity within the clusters starts to level off. The measure of homogeneity of the clusters is the total distance all customers collectively have to travel to get to their nearest store. We've created a graph in the upper right corner to plot the total distance traveled by all customers as we increase the number of stores. We begin by considering the case where we have a single store servicing all the customers. The store would be located at the center of all the customers in order to minimize the collective distance traveled. We add up the total of all the distances each customer travels and plot that data point in our graph. Next, we consider the 2-cluster solution. The 2 stores are located such that they minimize the collective distance traveled by all the customers to their closest store. Going from 1 store to 2 stores, we significantly decrease the collective distance the customers have to travel. We add the total distance for 2 clusters to our plot in the upper right corner. Next, we consider the 3-cluster solution. 3 stores are located such that they minimize the collective distance traveled by all customers to their closest store. In going from 2 stores to 3 stores, we again significantly decrease the collective distance the customers have to travel. We add the total distance for 3 clusters to our plot in the upper right corner. Now, consider the 4-cluster solution. The 4 stores are located such that they minimize the collective distance traveled by all the customers to their closest store. This time, we really don't gain much in terms of reducing the collective distance the customers must travel. We could keep going, but we'll stop here showing the 5-cluster solution. The 5 stores are located such they minimize the collective distance traveled by all the customers to their closest store. There is a smaller gain going from 4 to 5 clusters than from going from 3 to 4 clusters. The plot shows a kink at 3 clusters. After 3 clusters, we stop seeing large decreases in the collective distance traveled, so 3 seems like a good place to stop. Why do we need a computer for this? Computers are really good at doing repetitive numerical tasks. In the coffee shop example, we considered 12 customers. A commercial application might have data from a few hundred customers. With 12 customers, there are 66 pairwise distances to calculate in the first step of a hierarchical clustering. With 200 customers, the number is almost 20,000, clearly something you can't really do by hand. Also, in the coffee shop example, customers are described by only 2 dimensions, their longitude and latitude on a map. In a typical commercial application, it is not uncommon to describe customer needs and decision processes by as many as 20 dimensions. The distance calculations are more complex, and we can no longer visualize the data on a 2-dimensional plot. To give you a feel for the type of data from a commercial application, here is a stylized example of a survey of smartphone users who report on 2 things: their frequency of use of various tasks people use smartphones for, and their self-explicated importance ratings of various smartphone capabilities. To summarize, cluster analysis is a grouping algorithm. It groups objects, in our case customers, into homogeneous groups where the resulting groups are heterogeneous, i.e. different from each other. This concludes this video.